Hello, you are welcome back to Class Bridge. So in this lesson, we are going to be taking one example and we will use it to recap everything we have learned during the process of the first part of this course, right? Very good. Now, in this question, it said, given that a vector A is equals to 3i minus 2j plus k and vector B is equals to 2i plus 4j minus 3k. The first one is telling us to look for the cross product of A and B. In my previous video, I've taught us the process of solving the cross product, right? Very good. And question B is telling us to find the modulus of A. Now, if you are seeing this modulus for the very first time, don't fret. When we say modulus, it's still the same thing as magnitude. So if I will paraphrase this question, it will mean that find the magnitude of A, which is very, very basic and simple. Now C is telling us to find the modulus of B, which is also what? The magnitude of B. This D is telling us the absolute value of A cross B. You will remember I always say absolute value, which is still the same thing as modulus and it's still the same thing as what? Magnitude. So we are to look for the magnitude of A cross B, which is very simple too. The E is telling us to look for the unit vector of A and B. And F is telling us to look for the unit vector perpendicular to both A and B. Very, very simple. So let's solve this problem. Now it says solution. Now, we say given that vector A is equal to 3i minus 2j plus k, right? And vector B is equal to 2i plus 4j minus 3k. That's the question. So we have to look for A cross B. We have to look for A cross B, which we say we can represent in form of matrices. We have I, we have J, and we have K. And the component for A is given by 3, minus 2, and 1. For B, we have it to be 2, 4, and minus 3. Very good. Now, having this now, we can say A cross B is equal to, the first component is I. When we close the first row and we close the first column, what do we have? We are left with minus 2, 1, 4, and minus 3. So here we will be having minus 2, 1, 4, and minus 3. Don't forget that this will be plus, minus, and plus, right? Very good. The next one will now be minus j into, when we close the first row and we close the second column, what do we have left? When we close the second column, we are left with what? 3, 1, 2, and minus 3. We are left with 3, 1, 2, and minus 3. Also, we pick K. Now for K, we are to close the first row and the third column. We are left with 3 minus 2, 2 and 4. We are left with 3 minus 2, 2 and 4. So from here now, we'll be having A cross B will be equal to I into minus 2 times minus 3, that is 6, minus 4 times 1, that's 4, minus J into 3 times minus 3, that is minus 9, minus 2 times 1, that's 2, plus K into 3 times 4, that's 12, minus 2 times minus 2, that's minus 4. That's minus 4. So, evaluating that, we'll be having A cross B will be equals to 6 minus 4, that's 2, 2I, minus 9 minus 2, that is minus 11, minus 9 minus 2, that's minus 11, times minus J. So minus times minus will give us plus. So we have plus 11J plus 12 here. We have minus times minus. Minus times minus will give us plus, right? 12 plus 4, that is 16. That's 16K. It's as simple as that. Which means that A cross B is equal to 2I plus 11J plus 16K. This is A. Now let's see. B is telling us, question B says, find the magnitude of A. Find the magnitude of A. Okay. If we have a vector A, which is equals to xi plus yj plus zk, the magnitude of such a vector is equal to the square root of, please note that, x squared plus y squared plus z squared. Do you get it? So that's what we are going to be using now. So the modulus of A, which is the magnitude of A, is by comparing. You can see this 3 is equals to this x here. So we have 3 squared plus, into brackets, this y here is equals to minus 2 here. Can you see? So we have minus 2 squared plus this z here is equal to 1 because there's an invincible 1 here. So we have 1 squared. So this will give us 3 squared, that's 9. 9 plus minus 2 squared, that's 4 plus 1. So which means that our final answer, which will be the magnitude of A, is the summation of everything we have here. 9 plus 4, that's 13. 13 plus 1, that's 14. 14, the square root of 14. It's as simple as that. So let's quickly look for the magnitude of B. So just like what we did earlier, the magnitude of vector B will simply be 2 squared plus 4 squared plus minus 3 squared. And this will simply give us 2 squared, that's 4. Here, 4 squared, that's 16. Minus 3 squared, that's 9. So our final answer for that question will be the summation of everything we have under the square root. So we have it to be B equals to the square root of. So 4 plus 16, that's 20. 20 plus 9, that's 29. 29. It's as simple as that. So let's see question D. So we want to look for the magnitude of A cross B. So we have A cross B, right? So what's our vector A cross B? It is 2I plus 11J plus 16K. So that's what we have. And this will become, the magnitude will become very, very simple. That should be 2 squared plus 11 squared plus 16 squared. And this will simply give me 4 plus 121 plus 16 squared. That should be 256. 256. So my A cross B, the absolute value of A cross B will be the summation of everything I have here. So that should be the square root of 121 plus 4, that is 125. 125 plus 256, that should be 381. So we have it to be 381. It's as simple as that. So the E is telling us to look for the unit vector of A and B. So let's look for the unit vector of A first. So the unit vector of A is given by A equals to vector A itself, the actual vector, over the magnitude of A. Now, if you look closely, the vector A has been given, and that is what? Vector A is equal to 3I minus 2J, right, plus K. And we have also found the magnitude of A. So the magnitude of A is equals to the square root of 14, if you remember. So let's just plug them in now. So it means that our unit vector A will be equals to 3I minus 2J plus K over the square root of 14. And you can rewrite it if you want. You can write it as 1 over the square root of 14 into bracket 3I minus 2J plus K. It's as simple as that. That is our unit vector for A. So our unit vector for B. Our unit vector is given by B equals to our vector B over the magnitude of B. If you remember, our vector B is equal to 2I plus 4J minus 3K, right? And if you remember, we already have the magnitude of B, right? So our magnitude of B is the square root of 29, right? Which means that the unit vector for B will simply be equal to 2I plus 4J minus 3K over the square root of 29. And if you wish, you can write it as 1 over the square root of 29 into bracket 2I plus 4J minus 3K. It's as simple as that. F is telling us to find the unit vector perpendicular to both A and B. And we already know that the unit vector that will be perpendicular to both A and B is their cross product, because I've said that earlier in one of my previous videos. So we are now going to be looking for what? The unit vector of the cross product of A and B. So we already know that A cross B is equal to 2I plus 11J plus 16K, right? And our unit vector formula is given by A cross B caret is equal to the vector, the cross product of the vector itself over the magnitude of the vector. Good. Now, we already have A cross B. We have it already. Let me write it 2I plus 11J plus 16K. And we already solved for the magnitude 2 before. And if I can remember, that should be 381. The square root of 381. Right? Very good. Which means that our unit vector A cross B is equal to 2I plus 11J plus 16K over the square root of 381. And this will give us 1 over the square root of 381 into bracket 2I plus 11J plus 16K. It's as simple as that. So thank you very much. If you find this video helpful, please kindly subscribe to our channel, like this video, and share with your friends. Thank you very much. Till we meet again in our next class. Bye.